should. All right, everybody, we're going to do review of particle motion. This video is not for teaching. This is a review of that idea. So I want to start with the concept that a particle motion is some particle P, and we're only moving left and right with it. Guys, we're not tracking it X and Y. So particle P could be at 0 at time 0, and then it could go right for a while, and then it could change directions and go left for a while. It could change directions again and go right and go off the board. Everybody, here's the other big thing. It doesn't have to be at 0 at time 0. Guys, it could start over here to the right and start at +5, say. And it could go backwards first. And maybe it just stops here and it goes to -3. Okay? It can travel whatever. So again, when we're looking at this, maybe we say it's at 5 at time 0. Maybe we say it goes to -3 at time 2. Everybody, that means the particle went to here. Guys, it has traveled a displacement. It has traveled to a displacement of -3 at time 2. It has traveled a distance in 2 seconds of 8. All right? Everybody, if it turns around and goes back to, say, 6, at, say, time 7, because it doesn't have to go the same speed. Now, the displacement from 0 to 7 is, its position is 6. Its displacement, it moves how far? 1 meter. You guys agree? It's gone 1 meter. Guys, what is the distance this traveled? Well, it traveled this, which is 8, and then it traveled this, which is 9. Guys, it traveled 17. That's the basics of particle motion. And I think what's getting us is it just moves along the line. It doesn't have to start at 0, 0. All right? So what I did now is I just pulled up example 1 from the textbook. And it gives a function. And it says, hey, the position of a particle moving this way is given by this equation. Before we start, I want to be clear. Anytime you're given a position function, we know that the derivative of position is velocity, and the derivative of velocity is acceleration. Everybody, we can tell that because if we look at the units on a position versus time graph, the x is going to be time, the y is going to be feet. What's the units of the slope? Feet per second. So guys, the derivative of position has units of feet per second. That's velocity. Guys, if you take a velocity versus time graph, and it's feet per second and seconds, feet per second divided by seconds is feet per second squared, which is acceleration. Everybody, that is why. The graphs tell us that the derivatives work. That said, don't really want any of that stuff. What I want to do is talk about this particular problem. All right? So everybody, we were given a position function. All right? And everybody, I have the position function here. I factored it. I took the derivative, and we know what? That the derivative of position is velocity. Then I factored it. I took the second derivative position, which is the derivative of velocity, which is acceleration, and then I factored it. We're going to work through each of these functions to the graph, and then talk about these words down at the bottom. All right? So, everybody, if you want to know position, it is simply plug and chug. All right? It is simply plug and chug. I can plug in 0, 1, 2, 3, and 4. And the reason I like this problem is all the integer times gave integer positions. So everybody, time 0, 0, boom, the red curve. 1, 4, boom. 2, 2, boom. 3, 0, 4, 4. Everybody, there's the curve, right? That is just the position curve. Everybody, we can talk a lot about what this means. We can talk about position. We can talk about distance. Because we can see all the graphs right now, I can tell you that I know from 0 to 1 it travels 4 meters. Okay? But guys, I can tell you at time 2 it's at 2 meters. But if you go from 0 to 2, it has traveled 6 meters. Right? It's gone to 4 and gone back to 2. And again, you can tell all of that from here based on these graphs. All right? when you do not have the graphs, and again, you never get the graphs, right, everybody? You never get the graphs. You never have this picture. You have to make this picture. So we get here, and we say, okay, position is this function. This is factored. Guys, by the way, I love this problem because it factored. And you knew the position was 0 and 3. Guys, look at the graph of the S-curve. 3 and 0 are both 0, right? I take the derivative from the position function. 3t squared minus 12t plus 9. Awesome. Hey, 3's common. Factor out the 3. Boom. Hey, it's a trinomial. Guess what? It's factored. T minus 3 and t minus 1. Everybody, what do we know then? Right now, we know the velocity function is this. We also know the zeros. All right? And I can make it a little bigger. So often what we do every time, actually, not often, is we love to know where the zeros for the velocity are. Well, you can just tell once it's factored. It's 3 and 1. Guys, velocity of 1 is 0. Velocity of 3 is 0. All right, those are on this blue curve, guys, if you want to see the velocity curve, right? Right there and right there. I want you to see what happens on the red curve. This is tough. Guys, do you guys agree this is positive velocity? Right? Because it's above the x-axis. What's happening to the S-curve? It's increasing. Then the velocity becomes negative. What happens to the S-curve here? It starts going down because you're going backwards, guys. All right? And then it keeps going down here because it's all the way negative until it hits here. And then at 0 this time, and this is a little bit of a weird graph because it factors so nicely, but all of a sudden the velocity becomes positive, and so what happens at the distance? It stops going backwards and starts going forward. If I erase all these stupid marks I put on the graph, everybody, look right here. Forward, backward, forward. Look how that compares to the blue curve. Positive velocity means it's going to the right. Forward or to the right, same thing. Then the blue curve is below the x-axis. It's either going backwards or to the left. All right, then the blue curve's above. It's going forward. All right. Now we've handled 2 of these. Guys, the next one is to take the derivative of 3t squared minus 12t plus 9. The first derivative of velocity is acceleration, or the second derivative of position, right? Guys, this is an easy one. It's 6t minus 12. Take out 6. And again, I can plug in values in here, and I can make a little table, but I really don't care about anything but the 0. And does everybody see a of 2 has got to be 0, right? Everybody, this means, are you stomping on the accelerator in reverse or going forward? All right. Everybody, you're going forward, but the acceleration is going to the left. So what's happening? You're slowing down. All right, this is where it gets really hard. The acceleration in this section is still negative. Does everybody agree? But what is your velocity? Negative. So guys, this is like being in forward. You're going forward and you're coasting your car forward. Can you everybody picture sitting in the car? And you throw it into reverse and slam on the accelerator. Now this would be really bad. Do you guys agree? You're going to shear some gears, probably. But let's just pretend the gears can handle it. You're going forward, you throw it in reverse, you strap on the thing. You are trying to go backwards. But what has to happen first? You have to coast to 0, and then you start going backwards. But then everybody, what happens at here? All of a sudden you get past time equals 2. Whoops, it's green again. And the acceleration is now going forward. So now you were going backward, but the acceleration is positive, so you are slowing down. Everybody, this is called speed. This is just speed at the bottom, right? So let's be clear. This is speed, not velocity. And you have to consider, and here's the rule. I'll give you a rule, ready? If velocity is positive and acceleration is positive, you're speeding up. If velocity is negative and acceleration is negative, you're speeding up. And if they have alternate signs, guess what's happening? You're slowing down. And again, that's the condition here. everybody, I ask all kinds of questions on this, right? Sometimes I say, hey, what's the velocity at time 2? When is the particle at motion, at rest, right? It all comes from understanding this graph. So if I erase my stupid lines again, and I'm just going to grab the sheet we're going to try to practice after this, and I'm going to say some questions that were on it. When does a particle change directions? Guys, when does this particle change directions? All right, everybody, define when a particle changes directions. I'm really interested when the velocities are 0. Guys, I'm looking at the blue curve. Here's the zeros. Guys, the particle is going to the right. Now the particle is going to the left. Now it's going to the right. Guys, it changes directions at 1 and 3. Forward, backward, forward from our velocity curve. All right. When is the particle moving left and when is the particle moving right? Again, that comes from, that's the same question. It's just a different wording, right? Moving left, moving right has to do with velocity. So it's moving to the right here, moving left, moving right. Just different words, same thing. When's the acceleration 0? Guys, you don't even need a graph for that. You guys agree it's over here? Time is 2. Got to take the first derivative, second derivative, make it understand where that's going. Boom, on the graph, yeah, it's right there, the green curve where it crosses the x-axis. When is it slowing down or speeding up? We just did that. This is the difficult problem, right? Because again, you have to have both the velocity and the acceleration equations. All right, and you have to be checking signs. All right, you have to be checking signs. Positive velocity, negative acceleration, not speeding up. It's not speeding up. Negative velocity, negative acceleration, speeding up. Positive acceleration, negative velocity, not speeding up. Last one, positive, positive, guess what? Speeds up. And remember, you can speed up going to the right, and you can speed up going to the left, both ways. Guys, if you put the car in drive and hit the accelerator, you're speeding up forward. If you put the car in reverse and go backwards and hit the thing, you're speeding up going to the left. All right, the last one is the position stuff and displacement. All right, everybody, if I ask you for displacement at any given time, if I said, what's the displacement, what's the position? If I ask the position at any time, what's the position at time equals 3? It's 0. What's the displacement at time equals 4? 4. If I ask you the displacement between 3 and 4, this time, first thing you got to know before you say it's just 4 minus 0 is there a velocity change between 3 and 4? You take the derivative here, you find that you know where the zeros are. Guys, the velocity is the blue curve. I want to see between 3 and 4. You guys agree there is no velocity change? It's always positive. So guys, the displacement here is 4. Guys, what's the distance traveled? This time it is 4. They're the same. Everybody, if I ask between, say, 2 and 4, if I ask between 2 and 4, you got a problem, right? You have a velocity change. You guys agree? So what you have to see is between time 2 and time 3, where the velocity is 0, I travel 2 meters, right? And then I go 0 to 4. So my distance here, is 6. You guys see how that goes? 2 to 0, 0 to 4. All right? Everybody, what's my displacement from 2 to 4? 2. I was at 2, I ended at 4. Okay, it doesn't matter where you go, that's what happened to the particle. It moved 2 over those 2 seconds, but it traveled a distance of 6. Everybody, did I make it? I would love for us to do problem number 1 together. So can everybody read that? And let's start with this. I would love for you to find the velocity and the acceleration, because do we agree we're going to need all the derivatives? And then guys, let's factor those, okay? And I'm going to pause this video, or stop it, and I'll come back when I have answers. because it's already long.